Go ahead and pause the video and read this word problem here. I'm not going to actually go through the setting up the word problem. We actually set this problem up when we were solving linear programming problems by the graphing method. So you can read it. Just make sure you understand how the problem is set up. Like I said, it's a repeat of one we looked at earlier. But when we solved this by the graphing method, we actually got a solution for P to be $2,265 when X1 was 15 and X2 was 9. So let's look at how we can solve this a different way. Since this is a standard maximization problem, we're maximizing and all three constraints are less than or equal to a non-negative number, plus we have our non-negative constraints, then we can solve this by the simplex method. So really this is just another example of the simplex method for you. Now here I have 12x1 plus 24x2 is less than or equal to 480. So if I add a slack variable to that, that will convert that to an equation. And I can say 12x1 plus 24x2 plus s1 equals 480. And the second one says 9x1 plus 5x2 is less than or equal to 180. So if I add another slack variable to that, that'll give me 9x1 plus 5x2 plus s2 equals 180. And then the third one, if I add a slack variable to that one, I'll get 30x1 plus 30x2 plus s3 equals 720. And then when I move these numbers across the equal sign, they're actually negative. I see that I've got a couple typos here. These should be negative. So make sure you make those negative there. So when I move these across the equal sign, they actually change to negative 100x1 minus 85x2 plus p equals 0. Now I did change the signs over here, so they're okay here. Alright, so now if I write this in a tableau, let's write a column for each variable. We got to have a column for x1. We got to have a column for x2. We're going to need a column for three slack variables, s1, s2, s3, and we're going to need a column for our p, and then we'll need room for our constants. So the first equation here is 12x1 plus 24x2 plus s1 equals 480. So I just put zeros under s2, s3, and p there. My second equation is 9x1 plus 5x2 plus s2 equals 180. So put the 1 with s2 and then leave zeros with the other variables here. And then the third one is 30x1 plus 30x2 plus s3 equals 720. So put zeros under s1, s2, and p, and then 1 under s3. And then my last one is negative 100x1 minus 85x2 plus p equals 0. So I put a negative 100 here, negative 85 here, and then 0, 0, 0, and then 1 for p, and then 0 in the constant column. Now, the most negative indicator is actually in the first column. Negative 100 is the most negative indicator, so that would make this first column be my pivot column. And then my pivot row, I would divide 12 into 480 and get 40 for that quotient. Q stands for quotient. And then if I divide 9 into 180, I get 20. And then if I divide 30 into 720, I get 24. So if I look at those three quotients, the smallest of those three quotients would be in the second row, so 20. So that means I'm going to pivot where my first column intersects my second row. So that's going to be this this 9 that you see right here. So I'm going to pivot on that 9. Now, what I did in this example was to just save a little time and space. I decided that you guys should be experts now at doing row operations. So I decided I wasn't going to show you every step on these. I'll just show you what I get once I complete the pivot. So if you remember, we're going to pivot on this 9. So let's talk about what row operations would I need to do to pivot on that 9 so that I have a 1 here where the 9 is, and then a 0 above it, and then zeros below it. So obviously the first thing I'm going to want to do is convert that to a 1. So I would multiply that second row by 1/9. Now, so you need to do that on scratch paper. So I'll leave you to do that on scratch paper. So multiply everything here by 1/9. And of course that'll give you a 1 there, 5/9, 0 here, 1/9, 0, 0, and 20. But then after you do this row operation, not before, but after you've done this row operation, then you're going to have to multiply the new row 2 that you get by -12 and add it to row 1. And so that would be this row operation. That's so you can get a 0 here. And the other row operations you're going to have to do is you're going to have to multiply row 2 by -30 and add it to row 3 to get rid of that 30. So you'll have to do that row operation. And then to get rid of the -100, you're going to have to multiply row 2 by 100 and add it to row 4 so that you get rid of the 100 that's in row 4. Now, so again, get on scratch paper and take this and work through these steps to make sure that you can actually do these steps. Plus you can check my answer that way as well. Make sure I didn't make any mistakes. Okay, so this is what I got after I did those row operations. So I did those row operations, and this is the tableau that I got. Now in this tableau I only see one negative number, and that's down here at the bottom of column 2. So I got -265/9. That's the only negative indicator. So now I have to take these fractions and divide them into these constants. Now you might want to just do this with a calculator. So if you take 24 and divide it by 52/3, that actually gave me 180/13, which was about 13.8. And then if you take 20 and divide it by 5/9, that would be 20 times 9/5, which gives you a quotient of 36. And then if you take 120 divided by 40/3, that'll be 120 times 3/40, which is going to give you 9. And so looking at these three quotients, 13.8, 36, and 9, it appears that the smaller of the three quotients is actually the 9, right? So that's the smaller of the three quotients. So that means I'm going to pivot on this 40/3. So I went ahead and just copied that down. Obviously you could just do it from here, but I went ahead and copied it down here so you could see what I'm going to do. Now I'm going to multiply. I need this to be a 1, so I'm going to multiply row 3 by 3/40. So multiply everything in this row by 3/40, and then that'll make this a 1. And then once you do that, then you can work on eliminating the elements above it and the number below it. So after I've changed this to a 1, I'm going to multiply the row by -52/3, and I'm going to add it to row 1 to cancel that 52/3. So that would be this row operation. And then also I want to multiply the 1 by -5/9 and add it to row 2 to cancel this 5/9 right here. So that would be this row operation. And then finally I want to multiply this row by 265/9, positive 265/9, and add it to this row to cancel the -265/9. Now this obviously is going to require working with some fractions, but it's good practice for you. Okay, now if I do those row operations, what I'm going to end up with is this is my final tableau. And notice that, let me identify the basic variables for you. It looks like the first three columns are all basic variables. So x1 is a basic variable, x2 is a basic variable, s1 is a basic variable, and then the p column is also a basic variable. Okay, so if I were to label this, I would notice that the s1 column has the 1 in row 1, so s1 is identified with row 1. Notice that the x1 column, the 1 is in row 2, so row 2 would identify x1. Notice the x2 column is in the third row, so x2 would be identified with row 3. And then the p is in the fourth column, so p would be identified with row 4. Now, since those are your basic variables, then these guys are non-basic, so they're going to be 0. So now we can read the answer. Row 1 tells me that S1 is 84. Row 2 tells me that X1 is 15. Row 3 tells me that X2 is 9. And row 4 tells me that P is 2265. So putting all that together, I get the maximum is P equal 2265 at X1 equal 15 and X2 equal 9. And then as far as the slack variables go, we actually got a value for S1 this time to be 84, and then S2 and S3 were 0 because they were non-basic variables. Here's a little summary of the simplex method, and it says, first of all, write the standard maximization problem in standard form and then find the initial simplex tableau. Step 2, are there any negative indicators on the bottom row? If no, then you can stop. You have the optimal solution. But if yes, then you have to select the pivot column. And then step 4, are there any positive elements in the pivot column above the negative indicator? Now, I really didn't do anything like that, but if you go back to here, like this right here is my most negative indicator, and I actually had 3 positive values above it. But you might come across a problem where you don't have any positive numbers above this negative indicator, and if that happens, then you don't have a solution in that case. So that's why it's asking you that, because you can only use positive numbers up here in order to determine the pivot row. Okay, so it's asking you that, but we didn't run into this problem. So we will, if the answer, are there any positive elements? Okay, so if there are positive elements in the pivot column, then you go ahead and select the pivot element and perform the pivot operation. And then if necessary, in other words, if you still have negatives on the bottom row, return to step 2 and continue the process. But if there are no positive indicators above the number in the pivot column, above the negative indicator, then you have to say stop. You have to stop and say there's no solution. So, like I said, this is just a summary of the simplex method. Now, I'm going to work another example or two for this section. So be sure and see the next video to see some additional examples worked out for you so that you can maximize the amount of practice you get to see.